Chapter 4, Lesson 4, Part B. Still looking at complex numbers. Now we're actually going to perform some operations with complex numbers. Um, it's a lot easier than what you think. So let's just jump right into it. Adding and subtracting complex numbers. Biggest thing is make it like x's, okay? So when I'm adding and subtracting x's, okay, with variables, it's no different than with variables. So thinking about these i's as variables, I'm like combining like terms, okay? So same idea, little different concept because I is an actual number and not just a random variable, okay? So I'm going to combine my constant numbers, 3 and 2. So since this is addition, I don't really need those parentheses, so I can just look at the two numbers. 3 plus 2 is 5. 5 and negative 4. 5 minus 4 is 1. So 5 plus I. So same thing in letter B. It's addition. I don't really have to look at anything differently. I can just go straight in combining these like terms. So combining these constant numbers, 4 plus 3 gives me 7. Negative 6i plus 2i gives me a negative 4i. That's it. It becomes a little bit harder here in C and D with these negatives because again, I'm subtracting everything behind it. So one thing you might want to do is rewrite these numbers distributing that negative to both. So really I have a negative 3 and a negative 7i. Okay, so now when I combine these, now I can just kind of look at the numbers. 8, so 8 and negative 3 gives me a 5. Positive 2 minus 7 gives me a negative 5i. Okay, again, biggest mistake people make is they don't distribute this negative and they end up with 9i, 2 and 7 because they don't remember they're subtracting it. Okay, so distribute the negative in there, and then I can just combine those like terms, constants, imaginaries, and we're good. Okay. And in letter D again, let's distribute this negative in. So here I have a negative 6. Negative and negative make positive 7i. So again, I can combine the real part, the 10 minus 6. So 10 minus 6 here is 4. Combine my imaginaries. Negative 1 plus 7 is a positive 6i, and we're done. Okay, so that's adding and subtracting complex numbers. Okay. What about multiplying? So multiplying, we're going to take, again, it's just like when we have x's. We're foiling, using that FOIL method, the first terms, outer terms, inner terms, last terms. Biggest thing we have to remember is instead of an x squared, if I ever get an I squared, remember I squared equals that negative 1. So let's do our multiplication, but we're going to go about it the same way. So whatever process you like to use, that's what I would stick with whenever you're multiplying these, um, just like when you would FOIL with variables. So I like to take and multiply my front by the tops here. So 2 times 4 gives me 8. 2 times 5i gives me a 10i. And then 3i times 4 is a positive 12i. And 3i times 5i is a positive 15i squared. Now, so remember, this I squared is actually a negative 1. So this is going to be a negative 1. Okay, so I can combine these middle terms. 10 plus 12 gives me a 22i. 15 times negative 1 is actually a negative 15. And then I can combine, in the end, I can combine the real numbers there, the 8 minus 15, and get negative 7 plus 22i. Typically put your real portion, your real number out front, the imaginary part, the number with the I, in the back. So let's do letter B. So multiplying our 10. So 10 times 1 is 10. 10 times 4i is a positive 40i. Negative 3 times 1 is a negative 3i. And then negative 3i times a positive 4 is a negative 12i squared. So again, this I squared is going to give me a negative 1. So that makes this a positive 12. Again, if I want to combine my i's right away, I can. 40 minus 3 is a 37i, and that's positive. Bring down my 10, and now I can combine the real numbers here, 10 and 12. So 10 plus 12 gives me 22. Bring down the imaginary part, 37i. So 22 plus 37i. So that's multiplying with complex numbers. Again, the process isn't any different than what you've already learned. You're just applying it with the i's, and then the only thing we have to kind of remember is that I squared equals that negative 1. Little different concept here. Now, dividing complex numbers, and really it's simplifying this fraction, okay? Simplifying this fraction. So with division, imaginary numbers can't be left in the denominator. No imaginary values in the bottom of the fraction, okay? So how do we get rid of them? Well, we're going to use the conjugate, okay, to get rid of that complex number in the denominator. So the product of the complex number and its conjugate is always a real number. So we're a couple things. We're looking at, remember, I squared is always going to get me a real number. Anything to an even power gets me a real number. Okay? So that's one thing you're going to look at. Now, so in letter A, that's what we're going to use. All I have is a 2i. Well, there's no plus and minus in there. So what do I just need to multiply this bottom by? Well, I just need to multiply it by another I. And whenever I multiply the bottom by I, I'm going to multiply the top by I as well. Because then I'm only multiplying by 1. I over I is 1. So I'm not changing the value of it, I'm just changing the way it looks. Okay? So multiply this together then. So again, in the top, we're going to have to distribute that I. So I times 5 is 5i. I times I is I squared. In the bottom, 2i times I is 2i squared. Now, again, remember, anytime I see this I squared, negative 1. Negative 1. So really in the bottom I have 2 times negative 1, which now becomes a negative 2, and 5i, and a minus 1, right? So I can say minus 1 plus 5i. Now, they probably don't like the negatives out front, okay? I'm going to be not too picky with that, but typically what they would probably do is they would stick the negative out front, or the two negatives, and make it a positive. So they would change the signs here, okay? So these two negatives would be the positive 1. The 5 and the negative 2 would make it a negative 5i, and then the negatives would be a positive 2 on the bottom. Okay, so if you looked at it individually, okay, the 2 with both parts, you'd have a negative 1/2. So that's a positive 1/2, which is here, positive 1/2. And then you have the 5 over negative 2, which is a negative 5 over 2, and that's the I portion, which is here, negative 5 over 2. So we just changed the way it looked a little bit by adjusting those negatives a little bit to make it look a little bit better. But again, I probably won't be too picky with that. As long as there's not an imaginary value on the bottom, it'll probably be okay. Okay. All right. So in the second portion, okay, I can't just multiply by I, because if I do, you can see just like in the top, I still have an I in the top. Okay. One of them changed. Okay. One changed to a -1, but the 5 now has the I. So I can't just multiply this by I. But what we can do, and if you guys remember way back, there's a thing called a difference of squares. Okay, so if you remember difference of squares, it's the same thing, but one positive, one negative. So when I look at what I'm multiplying by here, if I have addition subtraction, I'm going to keep the same exact numbers, same exact order, 3 and 2i, but I'm going to change the sign in the middle. Okay, so when I change that sign in the middle, we're going to do the long division here, and you don't have to do long division whenever you solve these. But I'm going to do the long division here so you see it if you don't remember the difference of squares part. Okay. So I'm going to multiply these together then. 3 times 3 gives me 9. 3 times a -2i gives me a -6i. And then we're going to multiply the 2i. So 2i times the 3 is a +6i. 2i times a -2i gives me a -4i squared. So what happens is, you can see here a -6i and a +6i. This always is going to happen. The middle's always going to cancel out when I have one positive, one negative with the exact same numbers. These are always going to cancel out and give me a 0 in the middle. And again, just like before, this I squared, well, I squared is actually -1, right? So -4 and a -1 makes a +4. So really I have 9 plus 4, which then gives me the whole number 13. So in the bottom of this fraction, I have 13. And then in the top, again, we're going to multiply this 5i in. So 5i times 3, that's going to give me a 15i. And then 5i times a -2i gives me a -10i squared. So again, we get this I squared, which is a -1. Negative makes positive, so we end up with a +10 and a +15i, and that's what's going to be in top. So 10 plus 15i. Now, with this one, double check, can it simplify? Can 13, is there any number that goes into 13, 10, and 15? All three. Has to go into all three of them. Okay? So double check, is there a number that goes into all three of those numbers evenly? In this case, no. So we're done, and that's my final answer. Again, if for some reason, I'll give you an example here. So here's my final answer. Maybe, for example, then, what happens if I would end up with something like 10 minus 4i all divided by 2? Well, 2 goes into everything, okay? 2 factors into everything. So I'm going to take 10 divided by 2 and get 5, and 4 divided by 2 and get -2. So you can simplify that fraction then. So always double check it at the end. Is there a number that goes into all three? But it has to go into all three of them. So I'm dividing this by 2, by 2, and by 2. All three numbers have to be divisible by that same number, and we can simplify that. Okay? All right, that's your notes for 4-4. You can see the worksheet down in the bottom right.